Real-world computer programming for kids of all ages. Step 51. Quizzes and queries and conundrums galore. Los datos se han completado. Ahora lo consultaremos. That was for the Spanish speakers, or readers, I should say. The data has been populated. Now we will query it. We only have 21 records in our tables, but it will still be interesting and valuable to see how we can filter and sort the data we do have using SQL statements. To decide what it is that we want to see, we need to keep in mind what data we have, that is, which columns. They are the following, in human language, not the terse wording we used in naming the columns. Name or title of the movie, what type of movie it is, genre or genres, who plays in it, the actors, what it's rated, is it suitable for children, that is it rated G or PG or even PG-13 maybe? What other viewers thought of it, the movie's IMDb rating, which is an average of all ratings that august body receives, the length of the movie, how long is it, not in miles but in minutes, when the movie was made, is it new or old, how new, how old. I think we can assume that when we are searching for movies that we might want to watch, of all those pieces of data, the one we will need the most is the title, but the title is probably not something we would normally search on unless we already have a particular movie in mind and we just want to see the data for it. We may be curious about who wrote the screenplay or some other detail about it. So let's do that first. That is, look for a movie by its title. Now bear in mind that sometimes there are multiple movies with the same title. In the case of our data, though, 21 records, that's not the case. So when we search for the name or title of a movie, we will get either 0 or 1 records back. If we get 0, it means one of two things. 1, that movie is not among our 21, or 2, we misspelled it. Let's try each kind of query implied above. First, the search for a particular movie, and it shows a screenshot of that, the query statement and what was returned. So this gives us some information. This is all the data in the movies_main table as the SQL query shows using the star, select star. But it leaves us a little in the dark or even baffled. We might wonder, what does the movies_ID column give us? Who was the director? All we see is an ID value for him or her. Who was the screenwriter? Same situation, just an ID is shown. Who are the actors? What is or are the genre or genres the movie is categorized by? So let's answer these burning questions with some more SQL as we proceed. We'll skip the first question for now and answer who was the director. To find that out, we have to look him up in the director's table like so, and it shows the SQL for that and the result. So we see that the director of the 2019 version of Little Women was Greta Gerwig. By the way, I don't care if you're a man, woman, child, or a duck-billed platypus. You should watch this flick if you enjoy a good story and enjoy being transported back in time to another era and place. Normally, when a movie jumps back and forth in time, I am quickly lost as to what order things are taking place in, but Ms. Gerwig must be a genius because I always knew exactly where I was in the stream of time, watching her masterpiece. But we don't want to have to jump through those kinds of hoops to discover who the director was every time, right? We want to see the data all together in one place. So let's try this, where we take advantage of the relation between our tables. And it shows a relational query that's taking place. And then it says, this is probably the most complicated query we've done so far. Let's break it down, people. And it shows, printed now, that same query that we have a screenshot of. Here is where we see in action the relational characteristic of the way this database was designed. We can pull data together from multiple tables because they are related by a common value, namely, in this case, director ID. Do you see the M. and D. prefixes to the column names? They are declared in the from part of the SQL. M is the alias for the main table, and D is the alias for the directors table. So we pick which columns from M that we want to show and which columns from D that we want to view in the select portion of the statement. The keys, no pun intended, to bringing together the related data is the where clause, where we are stipulating that we want to grab the director ID value from the M table where the movie's title is Little Women. But then the relational part comes in with the and part of that where clause, where it's saying, in effect, get the D values from the record which has the same director ID value as the one in the M table for that particular movie. Pretty downright cool, eh, Daddy-O? Or Kitty-O? Now, on to the next question. Who was the screenwriter? We're dealing with the same situation here as we did with director. So you can suss out how the sequel needs to change to pull in the screenwriter's name too, can't you? Note, to suss out is another Britishism. It means to figure out something based on clues provided or evident. We need to add a relational piece from movies_main to screenwriters too, something like this, and it shows that. Sequel. Wallaby, it worked. But how did it work? I will bold what changed or was added between the last query and this one. And it shows that query again with the new parts bolded, showing data coming in also from the screenwriters table and matched together with a related part of the where clause. So we invited another table to the party screenwriters and drew on its relation to the main table via the screenwriter ID column's value. But wait, look at the data. Is it correct? It indicates that Greta Gerwig was not only the director in the first set of named columns, but also the screenwriter, second set of named columns, which have an _1 appended to them to differentiate them from the plain set of column names for director. By looking at the screenwriter table, you can see that yes, Ms. Gerwig wore both hats. She was director and screenwriter. I told you she was a genius. She is also an actor, as well as a Homo sapien. Of course, the author of the book, Little Women, was named Louise June Apricot or something like that, but she couldn't help what her parents named her. The next question, bellowing forth from a million throats, is who were the actors in said flick? Can you guess what we might need to add to the sequel to get that information? We will need to pull in the actors table, right? But there is no actor ID column in the main table, so how do we make the connection? What's the relation? Does the actors table have a movie ID column that we can use to connect these two tables? No. So what then? How about this? The movies_main table has a movies ID column. The actors table has an actor ID column. So is there a table that contains both of these columns? The answer is, drum roll, rumbles on with much bated breath, or bated breath if they want to go fishing later, among the audience. Yes, the many-to-many table actors_movies has both of those columns. So we can combine data from the movies main table and the actors table via this middleman, or the many-to-many relational table. So how can we alter our sequel to grab this data? While you think about it, I will write it. Here it is, and the screenshot shows that new sequel. If you know the movie's ID value from the movie's main table, you can do it as I did above, making that the first part of the where clause. The movie's ID value is the only part of the sequel you will need to change in order to update the results. Next question, you're up. What is or are the genre or genres the movie is categorized by? This is a similar problem as showing all the actors in a given movie. There is another many-to-many table, movies_genres, that will help us here. And this screenshot shows that sequel and the results set, the data that's returned from running that sequel. This is the same idea as the previous code showing the actors, but this time we are leaving out everything from the main table except for the title. Other movies have 3 genres assigned to them, and it shows a screenshot of that. The Princess Bride has 3 different genres, or sometimes only one. The Biggest Little Farm, a documentary, only has that one genre, documentary. The first one had 2. So there's either 1, 2, or 3 genres assigned to each movie. On to the next question. How can I filter the database by MPAA rating? If you want to choose among movies with a particular MPAA rating, G, PG, or PG-13, you can get this. It shows the results when you filter for G-rated movies, or this, showing the first 10 movies in order of length and minutes from shortest to longest, PG movies, which we have quite a few of, or this, and it shows a screenshot of PG-13. There's just a couple, 2 or 3. Next question. How can we filter the movies in the database by how popular they were amongst viewers? In other words, by popular vote. There are 2 ways. We can sort from highest to lowest, or we could actually filter out those below a certain real number that we specify. I'll demonstrate both ways of doing it. First, the sorting by most popular on the top to least popular on the bottom, and the screenshot is shown of doing that, and simply ordering by the IMDb rating column, descending. In the above, we did not filter the data. All the records display, with the where clause simply tying the directors and screenwriters tables to the main table. But we are sorting or ordering the result set, the data, and we are doing so DESC, descending, so the records display from highest, best rated by viewers, to lowest. Now, we will show just the top few records by filtering out those below a certain threshold. And a screenshot is shown of that sequel and the few 6 records that are returned. The first records returned with that sequel were the same as those from the previous query. However, as to the rest of the data, it was constrained by the where m.imdb_rating is greater than or equal to 8.0 part of the sequel. The final question, before we turn to some housekeeping or formatting issues, is when was the movie made? Here, too, we'll show 2 options. Maybe you want to see a movie filmed in a certain year for some reason. We will search for that. Alternatively, or perhaps additionally, you want to see all the movies between a range of years, say from 1997 to 2012. Here is how we search for a movie made in a particular year. Here we're showing 2019 as the chosen year, and the screenshot shows that, with only 1 movie returned. Now we will search for movies made within a range of years, specifically, as earlier mentioned, from 1997 to 2012. That screenshot is shown with that sequel and those results, 6 records, 6 rows. Now, as they say, meat first and spoon victuals to top off on. Now that we've got the data we want, how about its appearance? What do you make of it? What's your opinion about it? I dare say, in some respects, it is a multitude of times more unseemly than a carton of dilapidated odds and ends and stuff. I have 3 complaints in particular. 1, rather than have the name spread out over 4 columns, first name, middle name, last name, and suffix, middle name's often blank, suffix is almost always blank, how about combining it all into 1 column? 2, rather than have column labels in the result set that are the same as the database column names, which are only fit for geeks and propeller heads and such to look at, why not give them a more user-friendly name? 3, last in this list, but not least in the hearts of suffering mankind everywhere, how about 86ing the extraneous zeros after the IMDb rating values? In other words, make them display as 8.1, for example, rather than 8.1000. Note, to 86 something is to get rid of it. For example, if somebody were to look in the refrigerator and ask you, hey, what happened to the apple pie? You could, if feeling brash, respond, I 86'd it. If, on the other hand, you sense a certain danger in answering the question, you could 86 yourself from the house by diving out the window, with or without the sash. Let's take these challenges, as is our wont and is logical, in order. First, the combining of the 4 name columns into 1. We can take care of that this way, and it shows a screenshot with that sequel and the result. By using concat_ws and passing it as a first argument or parameter, a space, and following that up with the names of the columns that we want to concat or concatenate, combine, it does just what we wanted it to do. Puts all those name columns into 1 column. Now, for the column names to be more bohunkish, we can just extend what was already done above using the as to provide a new column title like so. And it shows how that's done. Finally, can we strip out those superfluous, extraneous zeros from the IMDb rating column? Yes, by changing m.imdb_rating as popular vote to trim, left paren, round, left paren, m.imdb_rating, column 1, right paren, as popular vote, as shown here. And it shows that sequel and the result, which fixes the problem. Now it just says 7.9, 8.1, no more trailing zeros. So, we are getting close to the end of the database-centric stuff here on real-world computer programming for kids of all ages. We still have a little bit to go, though. In the next step, we will talk about triggers, stored procs, and using a certain set of table columns to catch crooks in the act. Until then,